Okay, this is screencast number 3 for Unit 8, Lesson 5. And during this screencast, we're going to actually talk about lightning and thunder because they sort of go hand in hand. I had a young man ask me earlier whether, or to confirm, lightning is caused by two clouds bumping together, right? No, that is not correct. I don't know where you guys picked up the notion that lightning is two clouds bumping together, but that is not correct. Okay, so let's talk about what lightning is. All right, so I'm on, I don't even know what page because I didn't number these pages, but that's okay. Under thunderstorm hazards, where it talks about lightning, it says lightning is one of the oldest observed natural phenomena on Earth, and at the same time, it's also one of the least understood. Now, we do understand some things. We're going to talk about the things about lightning that we do understand. Okay. First of all, it says, while lightning is simply a gigantic spark of static electricity, scientists do not have a complete grasp on exactly how it works. Okay, so especially on a cold, dry day, if you've ever walked across a carpeted floor and then grabbed the doorknob and been shocked by it, that was because of a discharge of static electricity. And lightning's basically the same thing, but on a much, much larger scale. Okay. Lightning has been seen in volcanic eruptions, extremely intense forest fires, surface nuclear detonations like testing nuclear bombs, heavy snowstorms, and in large hurricanes. However, it is most often seen in thunderstorms. Okay, lightning is most often associated with thunderstorms. In fact, lightning and the thunder that results is what makes a thunderstorm a thunderstorm. So here we go. Okay, so I'm at the top of the next page. How is lightning created? The conditions needed to produce lightning have been known for some time. However, exactly how lightning forms has never been verified, so there is room for debate. Lightning is one of the most capricious and unpredictable characteristics of a thunderstorm. Capricious is sort of a word that means like something that does something without explanation or something like that. Okay? All right. Leading theories focus around separation of electric charge and generation of an electric field within a thunderstorm. Okay? And we're going to talk about how scientists believe that happens. Recent studies also indicate that ice, hail, and semi-frozen water drops, known as graupel, are essential to lightning development. Storms that fail to produce large quantities of ice usually fail to produce lightning. Okay, now, one of the things that you need to understand is when you see those large cumulonimbus clouds, the ones that are producing thunderstorms, they actually have a lot of ice crystals in them. The ice crystals stay in the cloud. It's not cold enough at the surface, for precipitation to fall as ice. But there are areas of the cloud that are cold enough for water droplets to freeze. Okay? All right. But if a storm isn't big enough, isn't strong enough to produce large quantities of ice, then they usually don't produce lightning either. All right, forecasting when and where lightning will strike is not yet possible and most likely never will be. Okay? Meaning that they can't predict exactly when and where a lightning strike is going to occur. Okay? All right, so we're going to talk about what goes on in a thunderstorm and how lightning forms in a thunderstorm. All right, first of all, it says thunderstorms have very turbulent environments, okay, meaning things are all mixed together, stirred up, okay. Strong updrafts and downdrafts occur with regularity and within close proximity to each other, meaning that you have strong updrafts and strong downdrafts occurring on a regular basis, and they are occurring close to each other, okay. Updrafts transport small liquid water droplets from the lower regions of the storm cloud, the lower part of the cumulonimbus cloud. And that updraft is going to transfer that liquid water to heights of between 35,000 and 70,000 feet, which is miles and miles and miles above the atmospheric altitude that we need for freezing to occur. Okay? But at the same time, meanwhile, downdrafts transport hail and ice from frozen upper regions of the storm. So remember, thunderstorms have these very, very, very turbulent environments. We've got updrafts and downdrafts occurring at the same time near the same spot. Remember, that's what this is showing you, updrafts and downdrafts side by side. Okay, so we've got updrafts bringing liquid water up, downdrafts bringing frozen water down. Okay, when these frozen particles collide with additional water droplets and ice particles, it says a critical phenomenon occurs. Electrons are sheared off of the ascending particles and collect on the descending particles. Okay, so what they're saying is, go back to your atoms. Think about electrons. Those are the teeny tiny little subatomic particles that are swarming around the nucleus. Well, when these ascending water droplets get mixed up with the descending ice particles, electrons are basically ripped off of the water molecules, the liquid water, and collect on the descending particles, okay? So we have all of this mixing, okay? And the particles that are being shoved up as a liquid and the particles that are being shoved down as a solid, basically these particles rub against these and rip electrons off, okay, for lack of a better word. All right, we have all these particles interacting with one another, shearing off electrons, okay? And I want you to remember that because electrons carry a negative charge, the result is a storm cloud with a negatively charged base and a positively charged top. Because remember, the pieces, the liquid water droplets that are going up have had their electrons removed, and so they're positive. And the particles that are moving down are the ones stripping the electrons off, and they're becoming negative. So you're going to wind up having a negatively charged bottom, okay, all these negative charges, and the top of the thundercloud is going to be positively charged, okay? So you have this big charge separation, okay? All right. Basically, guys, this is what happens. If you've ever walked across a carpet with shoes or something on, and you reach out and you try to touch that door and you get shocked, it's because the interaction between your shoes or socks and the carpet, one of them has had electrons sheared off, okay, and they've collected on the other surface. So there's a charge separation. And one of those objects become positively charged and one of them becomes negatively charged, okay? And then when you put your finger on the door handle, you've allowed a pathway for that charge to re-equalize, and that's how you get the shock, okay? All right, so remember, we've got negatives down at the base of the cloud and positives up at the top. Okay. So, as positive and negative charges begin to separate within the cloud, an electric field is generated between its top and its base. However, the atmosphere is a very good insulator that inhibits electric flow. So there has to be a tremendous amount of charge that builds up before lightning can occur. When that charge threshold is reached, the strength of the electric field overpowers the atmosphere's insulating properties and lightning results. Okay, so, and this is illustrated fairly well down here. You have a cumulonimbus cloud, very, very top. You have positive charges at the top, remember, because the things that went up got their electrons sheared off. So we have positive at the top negative at the bottom. Okay? And we've got to get a really, really large amount of charge separation before we're going to have an electrical discharge, which is what the lightning is. Okay? Now, the electric field within the storm is not the only one that develops. Okay? So there is an electric field that develops in the storm. An electric field basically is generated in an area where you've had charges that have separated. So there's an electric field that's been set up. But also, the negatively charged storm base, the bottom of the cloud, begins to attract positive charges on the surface of the Earth. So we actually get a second electric field set up here. You can think of the Earth as this huge, huge reservoir of electric charge. And some things, let their electrons flow around a little bit more easily than others. And so over a short period of time, with this large amount of negative charge sitting just above the Earth's surface, it's going to make any stray or loose electrons kind of skedaddle out of that area, and so this area becomes positively charged. Okay? And the positive charges are going to sort of make their way up the tallest object that's in the neighborhood. This is why you don't want to stand under a tree or next to a pole or things like that in a thunderstorm, because you don't want to be the tallest object and you don't want to be next to the tallest object. Okay? All right, so let's just go through this paragraph real quickly. The electric field within the storm is not the only one that develops. Below the negatively charged storm base, positive charges begin to pool within the surface of the Earth, down here. This positive charge will shadow the storm wherever it goes and is responsible for cloud-to-ground lightning. Okay? However, the electric field within the storm is much stronger than the one between the storm base and the Earth's surface. So most lightning, about 75 to 80% of it, occurs within the storm cloud itself. So when you have lightning, that electric discharge, okay, between positives and negatives, most of it is between one part of the cloud and another, about 75 to 80%. Okay? Okay, 75, I'm going to put it over here. About 75 to 80% is what we'll call cloud to cloud lightning. Okay? The other 20 to 25% is cloud to ground lightning. Okay, so a discharge between the cloud and the ground. Of course, that's the one that we're more concerned with because we're down here on the ground. Okay, but most of the lightning that occurs is going to be from one part of a cloud to another. Okay, so if this is kind of a whoa, that's a lot of information or kind of hard to understand, don't be afraid to go back and listen to it more than once. But if you don't learn anything else today, please make sure that you at least learn that lightning is formed because of electrons being stripped off and an electric field being set up. And lightning does not occur because of clouds bumping together. Okay?